See, as we have discussed how to reverse a singly linked list, right? What reverse means, suppose I have 4 nodes in the list, right? And in circular linked list, the last node will contain address of the first node and we are maintaining only the tail pointer. Tail pointer is containing address of the last node, right? So now what reversing means, we are not going to swap these nodes, right? What we actually do, we are going to reverse these links. See, here each node is containing address of the next node, right? But after reversing, what it should look like, this node would contain address of the previous node. We are going to reverse this link, right? Means now see, this node is containing address of the next node, that is 150, but after reversing, this node would contain address, this should contain address of the previous node, that is here we will store 500, right? This node also contain address of the previous node, that is we are going to reverse this link. So see, it is almost same as reversing a singly linked list that we have already discussed. Only difference is what? Now in this case, last node is containing address of the first node. But after reversing, obviously we are going to reverse this link also. So now this node is containing address of this node. Now we are going to reverse this. Now this node should contain address of this node, that is this node now should contain 600. So now we are going to reverse this link because after reversing, this should be the last node. And one more thing, now after reversing, tail would point here, right? So when you will display the linked list after reversing, then it should print -3, 6, 1 and 7. Now for this, how you will do this reverse operation? See, suppose at some point of time I have a pointer to this node, right? Obviously we are going to take some pointers, extra pointers, because we cannot move this tail, right? So for reversing, we are going to traverse the link, this list, and with the traversing only we are going to reverse these links, right? So now suppose I have a pointer temp pointing to this node. Now in this node, I should store what? Value of address of this node for reversing this link, right? So suppose I have stored temp of next equal to, from where I can get this address, in tail I have this address. So temp of next equal to tail. It means here I have stored what? Rather than this, I have 600 now. So now you can say this link is no more. Now this node is pointing to this node. Okay, fine. But now this link is no more, then how you will reach till this node? Because obviously we are going to reverse this link also, right? We need to reverse all the links. So now suppose by applying some logic, I'll tell you that logic, we have reached till here. We have moved our temp here, right? We will discuss that logic also when we will write that code. Now in temp of next, I will store what? This node, address of this node, address of previous node. So we have to maintain address of this node also, because if you move temp here, then how you will, from where you can get this address 500, because we have only one pointer left, a tail pointer is pointing to the last node, right? So now you have to maintain another pointer. Suppose I am taking previous pointer. So before moving temp forward, we are going to set this previous also. Now in previous we have 500, so we can write temp of next is equal to previous. That is also fine. Now you have broken this link, and now here I have 500, so this is now pointing to this node, right? Now how you will move here? So you need some extra pointer, one more pointer. So basically 3 pointers we need here. Fine. What you can do before setting this, before breaking this link, before setting here 500, what you can do, we can set, suppose, a pointer next node, third pointer to this node. And how you can do? In next node, we can write next node is equal to temp of next, that is 150. So here I have, in next node we will have 150, so this will point to here. So now you can break this link, you can set temp of next is equal to previous, and we have a pointer to next node also, so we can reach till this node, right? After that we can move this temp, then we will move this previous also, and the next node become this one. And now we are going to move till this node, right? Till we reach here, till the last node. It means we are going to take basically 3 pointers here. Rather than temp, I am taking what? Current. You can take any name, current, previous and next node, right? So see how you will write down the code for this thing. So as you can see, we have declared 3 pointers, pre pointer, current and next node, and These pointers are pointer to node because these are containing address of the node. So here I am taking struct node, right? This thing I guess you already know that user defined data type, the two parts are there of this node, data part, and one is next pointer. This will contain address of the next node. We have maintained only the tail pointer, right? So this thing this is what the global part, this we are going to use in all the functions. If you call that create CLL function, display function, or this function, so this thing I am going to write globally out of all these function and out of main function, you can say after header files directly, right? After that you can define this reverse function. Now see, we have taken 3 pointers. Now for reverse, obviously we are going to traverse the link, so for traversing we need one pointer, so I am taking that current pointer, that is main pointer. These previous and next node, you can say these are supportive pointers of this current. One is storing address of previous node and this will contain address of the next node, right? So first of all what you will do, now we are going to start from head node, from the first node we are going to start the traversing. So we are not having any head pointer, so how you can come to know that which node is the first node? So tail of next, this will always contain address of the first node. So how we can do, current is equal to tail of next. It means now current is pointing to this node. In tail next we have 500, in current now we will store 500. So now as you can see, this current is pointing to this node, that is to the first node, right? Now you can check if tail is equal to 0, it means list is empty. You cannot reverse the list, right? So you can after this you can write down this condition also. If tail equal to 0, it means list is empty, you can print this thing. Or if you want to print that thing also, that if suppose in list we have only one node, how you can check that thing we have discussed when we were discussing how to delete node from the circular linked list, right? If suppose only one node is there, then tail would point here and current would point here, right? And this node would contain address of itself, that is here also 500, here also 500. So you can check else if that tail of next is equal to tail, or you can say current of next is equal to current, right? In that case you can directly call that display function, or you can say that there is only one node in the list and only this. If 7 is the node, then 7 would be printing after reversing the list. Else we are having 4 nodes now. Now see what is the situation. Now how you will write this thing? Here I will write a while loop. While this current, because for traversing we are using this current node, when you will stop here, right? When this current becomes, when current will point here, it means current is pointing to the tail node. It means current becomes equal to tail. So we are going to move till current becomes, until current becomes tail. So current not equal to tail. Till then we are going to move this current, right? So before moving this current, obviously first of all we are going to set our previous pointer, right? So here you will write this prev is equal to current. Now this prev is containing 500. So now this is pointing to this node, right? Now only difference in this case is, now it should have address of this node, right? Because we are going to reverse this link also, right? But at starting we will not reverse this link, we are going to reverse this link at last, fine? Because if in while loop only you will write this statement. Now I can write previous of next. Here I want to store address of this thing, that is 600. So here I can write previous of next is equal to tail, right? So if you write that statement in while loop, then so when after some iteration current would point to this node, in that case previous would point to this node, right? Because this is the previous node. Now again that condition would be executed, means previous of next is equal to tail. So previous of next is this pointer now. So here you will store address of 600. So now this node would point to this node, but that we don't want. And after that previous would be this one, current would be this one. In that case also previous next is equal to tail. So again and again that line would be executed. So we don't want that thing. So first of all we are not going to reverse this link, we are going to reverse what? Next links. It means we are not going to change this value. It means we are not going to break this link, right? So this link is still there. We are going to break this link first of all. We are going to store here what? Address of the previous node, that is 500. Fine. And this link would be there. Still this link would be there. At last we will update this pointer. So now here obviously we will move this current now. So here you will write current is equal to, So now in current, what we need to store? The value of this node, because we are going to move this current now. Current is pointing to this, after that current will point to this node, that is 200, right? So now here how we can store this 200 in current? See, now here you need to set this next node pointer also. See, at starting we have set current is equal to tail next. So after this line, before this if statement, what you will write? You will set next node also. Next node equal to current of next. It means we have set both current and next node pointer. Now what is current of next? Current of next, that is 200. So here now I have 200. So now this is pointing to this node, right? So we have set both pointers at starting current and next node. After that you will write this if condition. If tail equal to 0, here you can print list as empty, right? And in else part you will write this while loop. Now see, in current what you will store? Address of this node. From where you can get address of this node? That is the next node is containing this node, address of this node. So now current is having 200, right? So now current is pointing to this node. Fine. Now we have set previous pointer also, current also we have, right? So now we can update this part. Here you will store address of previous node for reversing, that is 500. So here what I can write, how you can access this part? Current is equal to, current of next equal to, how you can access this part? Current of next equal to prev, whatever the value in previous node, right? So now see, prev have 500, so here we have 500. Now this node is pointing to this node. This link is no more now. So now see, the problem is next node is also pointing to this node. Now how you can reach till this node? So this thing you need to take care. You need to write which line first. So first, before updating this, we will move this next node. In next node we want to store 150. From where I can get 150? Here, before updating here I was 150. I was having 150, right? So here you can write before this line, next node equal to current of next. Current next means here before updating 150 was there. So now current node is pointing to this node, right? And now you can update this. Now current of next is equal to previous, that is 500. Now you can break this link. There is no problem because we have already set a pointer to next node, right? So now we are going to repeat these steps till here. See again while loop. Current not equal to tail. Current is 200, tail is 600. So that is fine, condition is true. Again we will enter into this loop. Now previous is equal to current, that is in previous we will store 200. So now previous is pointing to this node, right? Now we will move this current. Current is equal to next node. In next node we have 150. So in current we have 150. Now current is pointing to this node, right? Again we will move. Now next node should point here. Next node is equal to current of next. Current of next. Current is pointing to this node. So current next is 600. So in next node we have 600. So now next node is pointing to this node. So now we have set 3 links. Now you can update this value. So now here see how you will access this part. Link to this node is current of, only current is pointing to this node. So current of next equal to previous. In previous you have 200. So here you will store 200. So see what address of previous node is 200. So now this is pointing to this node, right? Again current is not null, tail. Current is 150, tail is 600. So the condition is true. We are going to enter into this loop again. See previous is equal to current. So here we will store now whatever the value in current, that is 150, right? So now you can see previous is pointing to this node. We will move this current is equal to next node. So here we will store 600, right? So now current node is this one. And now next node equal to current next. Now in current of next we have 500. So in next node we will store 500. It means you can see next node is containing address 500. That is now this next node would point to this node, right? To the first node. Fine. Current of next. Current is pointing to this node. Current of next is equal to previous. In previous we have 150. So here I will store 150. So it means now 150, this is pointing to this node, right? So this link was no more. Now 150. So this link has been broken now. right? Now we need to set this link. See, we have set all the links. Now you can see, say, current not equal to tail. Now current is 600, tail is also 600. So this condition is not true. So we are not going to enter into while loop. Fine. So now you need to update two things. Now we will set this pointer. See, this node is the last node now. So this node should contain address of this node now. Fine. Because this would be the first node, that is 600. Now how you can access this node? Pointer to this node is next node. Right. So here what you can write, in next node, next you will store address of this node, that is 600, and we already know the last address, the address of last node is always in tail pointer. So here I can write tail. It means next node next. Here I am storing 600. So now as you can see, this is pointing to this node. Remaining one thing is what you have to move this tail. Now in tail should point to this node, right? So in tail we want to store 500. So how you can get this 500? See, pointer to this link is next node. So next node is containing 500. So in tail I can store whatever the value in next node. Fine. So now in tail we have 500. So tail is pointing to this node, right? As you can see, we have reversed all the links, as well as tail is pointing to this node. And now when you will call that display function, then what the value should be printed? -3, 6, 1 and 7. So this is how you can reverse a circular linked list. See, after reversing, and this link is also there, no, not there now. Fine. So this is, I guess, same as reversing of a single linked list. Only the simple, the difference is what? Here the last node will contain address of the first node, right? So you have to take care of that link also, and that link we will update in the last. So after this you can write void main function. In that main function you can first of all create this linked list. You can call that create CLL function, then display function, right? Then output would be, before reversing, 7, 1, 6 and 3. Then you can call reverse function, and after that again you can call display function. So after that output would be -3, 6, 1 and 7, right? So in next video we will see the implementation of a doubly circular linked list. See, it was what? A singly circular linked list. Fine. So I'll see you in the next video. Till then, bye bye. Take care.